Okay, welcome to the second to last class in the Python set. Today we'll be focusing on strings, which is basically text data, and just began that at the end of last class. So we'll be picking off from the basics of just making strings and seeing what we can do with them. Just to begin, at the front of the handout that we should all have, I have the solutions to the assignment, quote unquote, optional problems that we had in handout 2. I also had the solutions in that handout itself, and I just have them in this again. I won't run down all of these completely, but I'll just point out a couple of things that may have tripped you up if you tried to do these alone. With this one, we wanted to make basically a Python function, which when we call the function, which we can see I do down at the bottom of my completed code on this side, we basically want a couple things to happen. We'll want to use the input function to accomplish prompting the machine prompting us to give some quantity, then prompt us again to do the math operation, and then one last time to get the last thing that will be multiplying, dividing by, subtracting. So we can essentially give those three things and kind of make a math equation, and then we'll write Python code that will do that math as we input it and spit out the response. So if we take a look at this, it's pretty much review of all that we've done. So up at the top, we input 3 times, and we just have little messages. We save all of those values as objects in Python as variables with names, so num1, num2, and the operation. The key thing that I want to point out, which is why I'm doing this, is that, like we mentioned last time, when we use the input function, it always saves the type of data that we give it, even if we type in 20, 5.5, anything that we type in, it's always going to think that it's a string type data. It's just going to save it as that by default. So even if we type in 5.5, it's going to save it just in the same way as if we inputted, Matt or Hamlet. It's just always going to kind of think it's text data, so it's going to save it as a string type data. So the key step is these 2 lines. When we take the float function and we input num1 and num2 into the float function, and what those output, which we just save back into num1 and num2, we just kind of update them, is kind of the floatified addition of those values. So if we put in 2.2 into the input, Python saved it as the text 2.2 to begin with, and then we want to say take 2.2 and make it a float if possible. If I tried to float the text Hamlet, that would fail and Python would crash. But since we can, if it's just a quantity with maybe a minus sign or a decimal point, that's fine. We can float it. So we'll save it as num1 and num2, and that's kind of the key point. In this, we just need to deal with those types and what's called casting from string type to, in this case, float type. And then you can see down this way, it's pretty simple. We just have a list or a list of if-elif questions, basically checking what operation that we inputted. We don't need to cast that. And then once we know what math we need to do, we just do the math. So it's pretty easy once we get down to this point. And then finally, at the end, I put a little bit of code that if we want to keep running calculations, we can ask that question. If someone says no, then we can just stop the function, which we do on this line. And elif, they say yes, or they say y in this case. I just call the function again inside the function. That gets a little complicated, but we can do that. And then it just keeps running the function again from inside itself until eventually we say no, and then it kills all the functions. The last thing I want to mention, back to kind of this casting point, when we want to take the string that we got from the input and make it into a float, we also have a bunch of casting functions. We have the string function, we have the int function, as well as the bool function, and they just take any value, and if they can, they make it into that type of value, a bool, a string, an int. The reason in this case we made it a float, we just assumed it would be a decimal, instead of using the int function, is that if someone had inputted 5.5 instead of just 5, if we tried to use the int function, well, you would have to check. It might crash Python because it sees a decimal and it can't make an int out of that. I don't know offhand, but it could just take 5.5, the string, and give it the int 5 and drop out the decimal. And that's kind of an equivalent bug, except it might sneak past us because we wouldn't see Python crash. So we might just get some faulty data without even knowing it. So that's why we used float. We kind of assumed it would be a decimal, even if we didn't give it a decimal, just so we could catch those cases when we want to do math with decimals. That's that one. With this one, you can take a look at it and practice it on your own. The thing that we'll mention is this random.rand int. This is a kind of a Python built-in function. It's available to us. It's not built in, so what we have to do up at the top is say, go get the random module. And then once we have kind of the random block of code that Python knows, we can say, out of random, get the rand int function. And what that's going to do is it's going to make a random int between 0 and n. In this case, n is equal to 10 by default. So it's just going to choose something randomly between 0 and 10, 1, 7, 5, and so on. So that's how we randomly generated something in this case. That's kind of the big thing in this one. And then kind of the second thing I'm just going to point out is, again, with the guessing game, we don't know how many guesses it'll take to guess correctly. So that's why it's best in this case of the two types of loops that we have to use the while loop, because the while loop can just keep going and going until we finally change the condition, this condition, guessing, which is just true to begin with. And we can just keep going and going until eventually, when we get to this block of code, my else, someone guessed the random int that was generated, and then we kind of switch the flag that was guessing to false. And then once we get to this line and we switch it to false, they say you win the game. We come back up to the beginning of the while loop, because with those, we just go top to bottom, top to bottom, top to bottom, as long as this condition is true. Once we flip this to false, we come back up to the top. We ask, is this condition still true? Well, now guessing is false. So once we come back up to the top one last time, it's false. So then we just skip all of this. We don't keep going. And then we come back to the call of the function at the bottom of the code, and then nothing else is beyond that. So we just kind of quit running all the code at that point. So it's a good example of the while loop when we don't know exactly how many times we might need to guess. This we did last time, so I'll skip past that. Just to remind us, we'll be using the command line known as the shell in Python. So this is my shell in Replit. So if we take a look, we did this at the end of last class. All my kind of basic commands that I'll use. Just to remind us, we have the ls, or the list command. And basically what that's doing is it's giving me the text representation of kind of my visual file management system. So what I'm doing in this box in the shell with my ls and my cd is the same as me just clicking on these visual icons on the side. I'm just navigating it with text and with commands instead. So my ls is list. My cd lets me go inside of any little box that I have in my file. So if I cd this way, then do ls again, now I'm inside this location, so I can see my w.py file. And I can then, the most useful command to us at this point, say Python, which says I want to run a Python file. And then I give the name of the file. And the key thing is I need to be kind of at the location of my file, which is why I had to cd into this location so I could see w.py, and then I could run the file. Looks like w.py is empty, so that's why nothing happened. But actually, let's change that real quick so we can just double check it's doing what we want. Yep, so when I Python w.py hello, I get it to come up. If I want to leave this box, I could do cd ... That basically is my back button. I leave that box and go out to the main box. ls list again. I'm now at my main level. And if I try to do the same thing, Python w.py, we can see, blah, 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 no such file. what that means is not that the file doesn't exist anyplace, but I need to kind of see it in my directory to kind of be able to use it at that point. Just like if we come to a, the laptop's file management system, if I want to open, a Zoom video, I can't just do it at my, kind of main level. I need to kind of CD into Zoom, CD into, this thing, and then I can do, Python, this video.mp to run that file. So it's kind of the same thing as just doing it with text instead of navigating it with the mouse and clicking and stuff like that. Yeah, so I have a couple commands listed in this, just the basic ones. All we need to just find the file that we want and then Python file name.py to run it. And that's what we'll be doing from now on. Because again, this play button up at the top, that by default always just plays the main.py file. So if we want to, in this class, have different files with each week, different projects and different files. Obviously, we don't want a million lines of code in just one single file. We'll want to make new files, new .py files, and then you need to use the shell command line to execute those files. That's my list again. This we did last time, and we won't use in this class, but that's up if you need it. And now let's just get to strings again. So again, this is my basic introduction to strings. We know how to make them just like any object in Python. On the left-hand side is the name of my box. Equal sign, that means I'm going to assign the following value to that object of that name, in this case, called name. With strings, you just enclose anything you want in quotations. And you can do it both with double quotes and single quotes. You just can't mix them. That'll break Python. So kind of choose one and stick with it. So you can see I did this one with double quotes, this one with single quotes. But if I tried to mix them, it wouldn't quite come out. Kind of the basic operation with strings, just like the basic operations with ints and floats is addition, subtraction, division, and multiplication. We use one of the same symbols. We use the plus sign, but instead of addition, it means concatenation. And that's just a fancy way of saying taking two strings, two pieces of text, and making one new piece of text with both of them in it. So kind of gluing them back to back in Python. So we can see let me play this. So we can see in my file, I have name and last name. I want to concatenate them into one object called full name. And I can see that we have it like this, and we can even concatenate multiple things at a time. As you can see, I have this blank white space in the middle, and that's because if I just concatenate the name and the last name, it just does those, so I don't get the white space in the middle. So we can just mix objects with just direct values like this white space and make exactly what we want like that. That's how we make that. The second kind of math symbol that we kind of use with strings is the kind of the multiplication symbol. Although in this case, it's just kind of concatenating itself 5 times. So it's just duplicating it 5 times. It might be useful to you, but I just want to mention that you can do that. The things that you can't do is you obviously can't do, you can't divide a string by 3. That's not going to do anything. It doesn't make sense. And you also couldn't take a string and, like -5 from it. And you couldn't even do something like this, hello minus the O. That doesn't quite make sense using these symbols. If we wanted to do that, we can do that, but we can't quite do it like this with strings. Next, we've seen this a couple times. This is just kind of a convenience tool. It's called the Fstring. It is basically a way of making kind of a big sentence in Python, printing it out to the console, and having less to type, really. So up until this point, we've had to do something like this if we want to kind of type out a sentence, mixing kind of static text and replacing these with the actual object values. So we have to open quotes, end quotes, comma, object name, comma, open quote, end quote, comma, object name, comma, object name again. But we can simplify it down like this. We just open quotes once and close the whole thing in one set of quotations. We put an F at the beginning. It can be a capital F, it can be a little f. And then anytime we want to not do static text, but replace book and name with the actual value, we just type it in and close it in these squiggly brackets. And then you can see in my output console, we get the sentence that we want printed out quite nicely like that. And we also don't have to deal with the bit of an issue when you have like double spaces and lack of spaces with just printing like this. We have to take into account, how many spaces we need leading and trailing and kind of find out how to do that. So we don't have that issue as well. It comes out exactly as we want. Down this way, just some optional inputs to the print function, which we know about. We know with the print function, it looks like this, and then we can put as many inputs as we want separated out by commas. And those inputs can be an object name. It can just be a straight value. It can be, a little bit of math or, any type of, function or anything that outputs a value. You can just stick in the print function and it'll print the output or the direct value that we want. But we also have some optional inputs that if we don't need them, we just leave them blank. That's why we haven't seen them yet. But we have these two. We have the sep and we have end. And we can kind of see what's going on. If I want to print 1, 2, 3, usually if I didn't have this, let's take this out real quick. If I didn't have that, by default, they would all be spaced by a single white space. That's the default. And that's the issue we ran into with this. We'd kind of have to take into account each of these commas kind of puts in a blank white space. So we might have to, delete this if we put it in by accident and, do all that. But if we don't want that default thing happening, we can set something custom. So we say sep equals, and then we put something inside quotes. So if I use this little pipe symbol, it'll come out as that instead. If I want nothing separating them, I can just put equals quotations with nothing inside. And then I get 1, 2, 3 like that. I could, if I want, put a \n, and \n is a special thing that means a new line. So we can see I have 1, and then a new line 2, new line 3. So I can use \n. I also have \t, and that means a tab. So I can have an equally spaced tab between all of them. So I could do that. And then finally, we have end, which does the same thing, but instead of in between each input, basically you do the whole print function, and then what do you do at the end of it? That's what that symbol is going to be. So we can see I have 3 print functions. They all print 1, 2, and 3. And instead of using the default of the \n, so default equals \n, which is a special thing, meaning new line. Now I get 1, and then instead of a new line, I put in some ellipses. Then I did 2, and then I did no ending. So I had a 2, and then since I didn't jump to the new line, which is the default, I just do the 3 at the end. So that's just a little way of tweaking the print function, and just a way of helping us realize that even though we've been using the print function and a couple different basic functions, they have a lot of capability that we haven't even seen yet, and a lot of stuff, especially like optional inputs that you don't need to know about, you can look up and use to great effect. Okay. So obviously, up until this point, we've gotten, the basics of Python. We know about the 2 types of loop, basically how can we run some set block of code again and again, either some set amount of times or some unknown set amount of times, and specifying a condition to keep checking until we stop running that loop again and again. So we know all the basics. We know about if, elif, and else, how to ask questions and only do a specific block of code if some condition is true. else if do something else do nothing at all. We can ask those types of questions so that the code we run doesn't always do the exact same thing top to bottom. We can have it dependent on the data we have, dependent on the condition, things like that. And most of the data that we've been dealing with is, quantities, and we've been doing, some basic math and things like that, adding up, summing, even counting. And that's pretty easy to see, even coming into Python. What can you do with math in Python? Probably the same things you could do as a human being. But it might be a little less obvious what you can do with string type data or just text type data. And this is just a list of some of the basic things that we might be able to do. We've seen that we can just do exact matches. So just like we can ask Python, let me come to my console and ask questions, a quality question. So is 3 equal to 3? Is 3 less than, above or equal to 2? That's true as well. We can ask these questions about math and quantities. We can do that with strings as well. So we can say, do we have an exact match? And that might be something that we use when we log into a website and we want to see, did the passcode they input match what we have on file? So we can do that type of thing. And we can begin to see it's quite exact. So if we don't have case sensitivity, we have a capital H and then a little h, then we get a false. So we can do exact matching just to see if something matches like that. We can also do types of matches, and we'll see this in the class. So instead of matching an exact piece of text, we can logically explain a piece of text. And one example is like an email address. So we'd be able to code Python to kind of identify and do anything we want with that once we find it, but identify an email address and always find it and kind of exclude anything that doesn't match kind of how we specify. And we'll do an example of this in this class, but we can kind of imagine as human beings, how do we identify an email address? Usually they look something like this, but sometimes they don't always look exactly the same. They don't always have the same ending. It's not always at gmail.com. It's not always .com at all. Sometimes it's .net. Sometimes it's at college.edu, things like that. But we can use logic to kind of specify a trend between all of these. And one obvious thing might be any email address is always going to include at least one thing, and that's going to be an @ symbol in the middle of the email address with something on the left side and something on the right side. And we could add a few things to that. It's going to be alphabetical and digits. It might have a couple periods and things like that. But we can use those kind of things that will kind of show up in all of them to do matches. And obviously we can do things like counting frequencies of a piece of text. Like we can count the lines in Hamlet. We can count how many times Hamlet himself spoke, how many times they said, ghost and things like that, if you want to do kind of textual analysis. Or if you want to grab some data off social media and say, how many times do people talk about this event in the news, see if it's trending, things like that. So that's the kind of things we can do with text data. And then kind of the simple things is just the concatenation, which we've seen. So we can take 2 strings, take multiple strings and make one big one. And then we can also do the opposite, take a big chunk of text and kind of chop it up into pieces. And we'll see in this class how not to just to like chop it up evenly, but how to, again, say, take the play of Hamlet, which we could save in Python as just one single data object, which is a string, and it could have, 10,000 lines in it, but it would still just be one string. We could tell Python to automatically go in, somehow logic into finding out how to split up each line of the play. And if we go to let's go find the play. We can kind of see how we would do it as humans. So if we take a look at the play, how could we tell Python to kind of identify the beginning of a new spoken line of text? well, eventually you know how to tell Python, we'll find any capitalized name followed by a period, followed by a new line, and then that lets you know it's a new spoken line. So Python would say, oh, capitalized with a full stop and a new line. This is a new line. This is one line of dialogue. It would get to something like this and say, okay, capitalized name, full stop, new line. And then it would just keep going and say, this is one long spoken line of dialogue. And it would save that all as one line until it got to the next match that it found, which is, again, a capitalized name with the full stop and the new line. So that's how we can kind of think of it as human beings. That's how we would do it. And then we'll be able to tell Python how to do those kinds of matching and things like that. So that's how we'll be able to cut it up, find the match, and then we'll find out the syntax to say, okay, at this point in the long string, chop this out and put it as its own string in a Python list, as an example, something like that. Okay. So in this example, this is just a pretty simple example of something that we talked about. We have a simple function, check my passcode. Obviously, on actual websites, it's not quite this simple, but just as an example, it's fine enough. So in the machine, we have the passcode saved, and then just like a website would prompt you to input the passcode, we could do that in Python, save it as something called attempt, and then just do a simple equality check. If the attempt matches what we have on file, we'll say we checked it and it's true, it is the passcode. Else, attempt failed, give back false, and then this check passcode function could be used, in the code of a website to log someone in or kick them out if they, don't have a true account. Okay. So this one, this is when we might have a list of people. So we'll go down to the bottom of the file because that's when we set up the data and call the function that we have up above. So say we have a list of people attending a celebration, and we want to basically count the amount of people in that list, which we could do with the length function or the len function, which I'll remind us of. We have the len function. We can put in any type of object like a Python list, and it'll count how many things we have inside of it total. But one thing that we'll notice is that if we have duplicates, it keeps counting them. It doesn't say only count unique things, it just counts everything. So same with a string, it counts the H, the E, both L's and the O. So we can't quite use that in this case. So what we'll do is we'll need to make a custom function to say we want to count each thing in the list, but we want to keep track of something we've previously counted. And if we have, we won't count that again. So we'll set up a list of names. We just have two duplicates. We have John twice, so that's kind of the test to see if we don't count that twice. And what we'll do is we'll spit that into the function that we make. So we'll spit that in. We have the same piece of data now inside the function. And what we've basically done is we make a new list, a new blank list, just called check. And we also have something called count. That one's easy. That's just how many people as we count them. But the key thing in this is the checklist. So each time we get a new name, beginning with John, we add it to the checklist. And then when we get the next name in my loop, getting the names one at a time, I added John, then I go to the next name, I get to Joe. What I'm going to do is say, if name is not in my checklist, so check just has John at this point, so I do pass that check. Joe is not in the list that just has John, so I go into this if clause. And what I'm going to do is add Joe also to my checklist. So I say, take the list check, append it, take the name Joe, append it to check, and then I'm also going to +1 to my count. And then I do this again, I add Jill, come back in again, I get to the last name, which is John, and it should be in check. So if John not in check, I should skip this because I've already added John to check. I kind of have my duplicate list to see if I have duplicates. So I should skip that and I shouldn't count it one last time. But what we've seen at the beginning of the class is that Python is case sensitive when you deal with text data. So I have John capitalized on this side, not capitalized on this side. So a new function that's available to us is this basically capitalization function. And what that does is it takes anything that you give it and capitalizes the whole thing. And so I can basically make double check that everything is fully capitalized. And also when I put it into my checklist, I'm also going to, again, fully capitalize it and then save it into my checklist so that when I come back on the next loop and say, is this name capitalized in check? I'm checking a fully capitalized name against a list of fully capitalized names. So I don't have any issues just due to, case typos. I chose capitalization. We also have the opposite, obviously. So down this way, you can lowercase things like that. We also have available to us this function. And this function is giving back a Boolean value. So instead of capitalizing it or not capitalizing it, it's basically asking, is the thing I'm attached to capitalized? We can see Tom is not, so it gives back false. If I try that again, it's going to give back false as well. And then finally, if I try it one last time, it'll give back true. So you can see in this case, everything has to be capitalized to give that back. And likewise with, kind of the opposite function like this, we can check if everything is little case. So you can see pretty simple function that we had to make, but a couple things that we had to deal with to get to the end result in Python. We had to make that second checklist. We kind of had to think, how can we check against duplicates? Well, let's just make a second list. And every time we check a new name off the actual list, check to see that it's in that, hasn't been added to that checklist. And then we also had to deal with case sensitivity. And then the new thing as well is I have my second use of the in key phrase in Python. So again, if I come into my console and I look at kind of all the key Python vocab, that's kind of my Python commands, we can see in is one of them. We've used it once already, so we know what this line is doing when I make a loop, taking all the elements in this list, and giving them back to me one at a time and naming each element one at a time, name in this case. So that's breaking my list down into individual elements, and then I loop each one at a time. But in the second case, this is a new example. I'm saying if name not in, and you could also say if name in check. I just chose to make it, the negative addition of it. This is kind of basically doing the same thing. It's taking a single element, just name, and it's seeing if it's in a collection of things. In this case, check is a list. So that's a bunch of things that we can check it against. So what this one is doing is it's kind of running a loop. It's taking name and checking it against each element in check, which is a list. And if we have any exact match, it gives back true. And if it doesn't find it at all, it gives back false if I'm asking in check, or in this case, not in check. So it would, do the opposite. So this is my second use of in. I can just check a single thing against the whole list to see if that value is inside the collection. Okay. At this point, I'm going to, I'm pausing my, apologies about this. I'm going to pause the videotape because I'm actually taping this after the class. I missed taping the beginning, 10 minutes of the class. So I'm going to switch to the actual tape of the class. I'll be at the same slide. I might have already done something I'm about to do in a second, a day ago to me. So apologies if it's a bit confusing to you. Okay. So we can take check the blank list and add names to it one at a time. So we'll add name to the end of the check list. And then what we'll also need to do is add one to count. And again, we could do that like this, kind of the long name, the long way. Take the old value of count, add one to it, and then update count. But this is also the same thing as just doing this. And this just means basically update count by adding one into it and updating it that way. So these two mean the same thing. One is just the abbreviated way. And then what we'll need to do is all the way down at the end, once we finish all this loop block, we get down this way. Let me pull this up a little bit. So when we get to this line, we've escaped the loop. And then we can just spit back out the count to see if we had that many people. Actually, I guess we said, well, let's think about what we want to do. We could spit back out how many people that we have, and we could just do count, but we could do something like this. If we want to spit back out a true false and make this a function to basically say if a list has a duplicate in it, we could do this. And if basically we have like a count of 5, but the list has 6 in it, then we know one of them was a duplicate, and that would give back a false, or maybe a true, meaning we had a duplicate. But we'll go ahead and just say spit back out count, and it'll give back amount of unique people in any list. So we'll set it up that way and do that. So we'll come back down, say we will accept an output called count, and we'll call it count on the outside as well. And then we'll just go ahead and print out count. And then let's go ahead and see, we'll push play, see if we did any bugs, see if we could fix it or add on anything in any way. We come to my shell, do Python w3.py. And let's see, so it counted 4 people. That's how many is in the list, but we can see it didn't quite do what we want. We wanted it to not count John twice. So we can see we have a little bit of a bug, it seems. But what's actually happening is if we come to the console, let's check one thing. Let's check to see if John is the same exact value as John without the capital. And we can see that actually comes back out to false. So in Python, like in most languages, when it comes to strings, you have to match exactly. So capitals mean something. Empty spaces, so like if I had this, also means something. So we have to watch out. And when we deal with strings, we have to deal a lot with checking to see that everything is capitalized the same way and things like that. So we can add one last thing into this function to basically fix a faulty list that just doesn't pay attention to case sensitivity. We can come into the function itself, and we'll say we want to loop the list of names one at a time. And this is the point that we get the issue. We check John against, the not capitalized John. So what we can do is just say, take that name, and we can say, just always capitalize it. So we could say, this is a dot notation function, just like the dot append function. It basically does something to the thing it's attached to. So it's going to take that name and totally capitalize it. And then what we'll also do is down this way, when we make the checklist, we'll also stick it in the checklist fully capitalized, so that when we go back and check it, we always checked, like fully capitalized name against a list of fully capitalized names. The opposite one, you could do it the opposite way, totally the same thing. This is to make it all lowercase if you want us to do it that way. I just chose to do it this way. So let's come back, get out of the console, come back to the shell. Let's try this one last time. We can see we get the 3 come up, so that's good. Let's do add to this list a little bit just to kind of double check. So we'll add an additional duplicate of John just to see if that affects anything. That looks good. Let's add in like a John, just to see if that does anything. And it doesn't. That's a different name at this point. So it looks good. We can obviously add to it. Obviously, you might have a list of names of a full name. So you might have a John Smith and a second John, who is, John Brown. But the same logic would apply. You would check the whole string against the whole thing. And then, it would be the same. But as of now, this looks pretty good. So in this one, we did the second use of in, which is just basically check to see if one thing is inside a list of things, which we did with the name inside of a list of names. And then we also did how to capitalize strings. And the opposite is this. And we'll see some additional methods to deal with that in the second couple of examples we have in this class. But that's all we should need in this function. We'll do a quick second example just to see this again. Okay, so we'll make a second thing called digit check. And we just want to check if some string, we'll kind of add that in a string with digits. And this might be something like on a website, if we ask someone to put in, a telephone as a, contact info, we might want them to give it to us without dashes and things. So this might be what we might implement. So we just get the digits and we don't get the hyphens and things, because people might put in hyphens, some people might put in spaces, someone else might put in the parentheses. So this kind of thing we could implement to get the same type of data from people. And this is what we can do today. We could also do with strings once you go on, knowing what you can do with them. You can take different types of data or different instances of data, like a telephone that, in one case has parentheses and hyphens, in a different case has spaces. And you could use like string methods like we've begun to look at to make them all the same automatically. So you could do that as well. But this one is kind of the simplest way that we could kind of deal with that issue right now. So we could say, and we'll just call this telephone if we want to get someone's telephone. So we'll split up telephone one at a time. And then we'll just say, we'll just ask the question as we always do. And since we just want to check if it's only digits, we can kind of just do that manually just by doing something like this, since we'll get it one at a time. If it's not a 9, it's not a 2. If it's a hyphen, if it's a space, if it's a parentheses, then it'll fail this check. So something like this would pass, because when I get to each of these one at a time, it's only digits. But if I did something like this, this would fail multiple times because I have parentheses, I have spaces, I have hyphens. So that would fail my test. So what we can do in this case is we'll loop the whole thing. And anytime we don't get a match of it not being a digit, what we can just do is finish checking the whole thing right then, because we just want to check if anything is not a digit. So if we get to one that's not, we can just end the whole loop, end the whole function, and give back out a false. And that's what we'll take on this side. But if we do the whole loop, come down this way, we'll give back out a true, because all of them came out to be digits. So we could do this. Let's put in a phone number to check, and we'll print it out. And then we'll go ahead. I'm just going to comment this out so it's not in the way. And then we'll go ahead and see if this is good. Oops. What did we do? Oh, yeah, so we had a little bit of a bug, which I put in intentionally, but then forgot about it. So we put in this, which is just an int at this point. But what we can't do, and we can kind of see it down in the traceback, is that we can't take a quantity and break it up into like the 9, then the 7, then the 3. We just can't do that with ints and floats. We can do that with strings though. So all we have to do up at the top is just update telephone to be a string. So we just put this up at the top, and then something like, we'll get something like this. If we had a phone that's just 973, which is an int, we'll get it now basically in quotes, and that would make it a string. So we'll take this and update it to a string. And then when we get to this line, when we break it down and loop it one by one, we can only do that with like strings and lists and things like that. We can't do that with ints and floats. So we'll just have to do that in this case. So things like that, even though we set up the problem quite easily, little things like this, changing between types depending on what you need to do. That's like a lot of, Python encoding. It's just the little things that add up. The logic of, asking these couple questions was quite easy. It's just, kind of the technical issues that can bog things down. So let's see. So we got the true down at the bottom. So that's good. If we change this to be something like this, let's run that again. And then you can see we got a false because we had a couple, non-digits. So that's how you would implement that manually. Python has something like this built in, which I'll just show you now. But it's always good to know how to do things manually, just as practice and just to get the basics down. So down this way, Python has something called isDigit, and it basically takes something that you attach it to, and again, it's this kind of string method. So I just put it, or this dot method. I just attach it to some object. It could be just a value like this. It could be something like this when I print n.isDigit like that. And then it'll just give back true, false, depending on if it's all digits. Let's see what this does. This is just the built-in thing of what we just made. We can see we get a bug. And it just says, this is an attribute kind. So it says int object has no attribute isDigit. And that might take a little bit to get used to exactly what that means. But basically what it is telling us is dot isDigit is only a string method. So you can only attach it to strings. You can't attach it to something like this n that we just made because it's not a string. So we can't do it, and it kind of doesn't make sense to attach it to a non-string. If I have an int, if I have a float, I kind of already know it's all, digits anyway. So this is a string-only method. So I'll comment that out since we can't use it. But we can see with isDigit, when I attach it to 1, that comes out to be true. If I can do it to something like this, that'll be the same thing. It's just checking the whole thing. But then as soon as I put anything else in this, I just need to get one non-isDigit, and then the whole thing will fail. So isDigit, the native way, operates the same exact way that we just set up with this homemade function up above. Okay, we'll do one last kind of big example, and then we'll move on to the main lesson today, which is called indexing. But we'll just do one last thing to kind of get a couple of these new methods like this and like isDigit. So let me do one last thing up at the top. Put some space and take out these print statements down below. And what we'll want to do in this one, I'll show you kind of the question on this side. So we'll do a passcode check. Well, we did the passcode check when we just want to match to see if what we type in is what they have, on file in the website. In this case, we want to make a function that allows someone maybe signing up to a website to make a new passcode. And it's going to operate exactly like you would when you sign up to a website. You'll get prompted to type in a passcode twice to see that they match. And then you have to do a couple things as well to make a legitimate passcode. So you'll type it in twice. You'll want to check when they type it in that it's at least 8 things long. So that's criterion 2. And then the last thing we'll have to do is we'll need to check what they typed in has at least 1 capital, 1 little case, 1 digit in any one of the following couple punctuation symbols that I have listed. And then what we'll do once it does all that checking, it's just going to spit back out true and false, depending on if they successfully made a passcode as is allowed on this website. So we'll do all that. And then that'll be the last example. Then we'll do the next big lesson. So I'm going to come in, make a new function, create PW. I'm just going to call this function, so I don't need to give it an input. In fact, I'm going to use the input function inside of this to get the passcode prompted twice. So we don't need to accept anything at this point. So we'll just leave that blank. In the docstring, we would typically put this whole thing. I'm just going to put a couple points of it and not type it all out. So I'll say prompt user to type in password twice, check that they match. Thing 2, PW must be at least 8 characters long, and then we must have 1 capital, 1 lowercase, 1 digit, and we'll just call it special, but we'll get the list in a second. So this is the basic things that we need to do in this. And then at the end, I'll say gives back true/false based on success of making allowed passcode. Okay, so that we can type out when we have time. We'll go ahead and begin to make this. So this one's going to be pretty long. We can see just by peeking at the solution, it's this whole thing. So it's quite a couple steps that we need to do. So in this case, we'll take a step back from just jumping into the code, and we'll actually plan out the whole thing just using comments so that we kind of have a game plan in mind, and then we'll go back and fill in the code. So what we'll do is we'll just kind of use comments to say, this is step 1, this is going to be step 2, this is going to be step 3, and then we'll come back in and put the actual code in a second. So step 1 is prompt with the passcode twice. And then maybe inside of that, we'll say, check that they match. If not, keep prompting. So we can kind of guess with that. We kind of did that at the beginning of the class. If we fail, we just kind of maybe put it in a while loop, and we'll just keep prompting until we get ones that match. So we'll kind of have a while loop in a second. Once we have 2 passcodes and they definitely match, we can move on to the next couple checks. So we can check the length, at least 8. That'll be 1 check. Then we can do kind of the last thing, which is going to be a couple things at once. We'll kind of check those conditions. So we'll say 1 capital, 1 lowercase like this, 1 digit, and 1 special, which is like punctuation. And then all the way down below, we'll just kind of fill this in and swap it out once we get to that point. So this process, actually, when you plan out all the steps and you just kind of basically put it in human language, so it's a little code-like because we have the indents that we might expect. Like we expect this is going to be a while loop, so I indented it and things like that. This is actually called pseudocode. And it's basically exactly what we did. It's just not jumping straight into the code. It's, planning out the whole function in a mix of English and Python ahead of writing the code. And that just helps you, not write 20 lines of code and then realize you didn't think out the whole problem and you have to go back and do it all again. So we can just kind of break it down. And now that we have all this, we can kind of do these in any sequence that we want now that we know that step needs to exist. But we'll just do it top to bottom, obviously, anyway. So we'll come up this way. And we can see we've missed a couple things. So I need to prompt for the passcode twice. That's going to be like an input, maybe. So I'm going to leave these pseudocode lines and just stick in the code in between so I can still see both at once. And then let's go ahead and set this up. So I'm going to have some while loop. I don't know the condition yet, but I'm just going to leave that like that. And I'm just going to make an object called PW1. And what I'm going to do, this is a little bit from last time, this \n and \t. This means new line and tab, and we'll kind of see what that does in a second. But it's just basically going to tidy up what comes out in my console. That's one of them. We'll kind of do the exact same thing with PW2. So I'm just going to copy that line. I'll call the second one PW2, so we still have them as two separate data objects. And I'm just going to say this instead. So that looks like it'll come out. And then we just need to implement this, and then we can begin to test it a bit by bit. But obviously, we can't even run the function yet because this is not Python. So let's keep going a little bit and just finish off this block. So let's see, we got PW1 and PW2. So then once we have both of those, we can just kind of ask, is PW1, and maybe we'll say if it's not equal to PW2, then we'll print out try again. And then that'll jump up to the top. And then, what else is going to happen if they do match? Well, we'll need to set up something in that case. But the kind of tricky thing about this is we need a condition that we can ask when we don't have any passcodes at all yet. And we also need a condition when they, once we kind of have them. So we'll take a look at the actual solution that I have, and I'll kind of explain it. This is just the way that I thought of it. You could maybe implement it a different way. But basically what I did is up at the top of the function, I initialized PW1 and PW2 just as blank strings. So I just had quotes with nothing in them. And then I just said, well, PW1 is equal to blank. So that allows me to get it going. It's equal to blank at the beginning, so I can jump into asking for the passcodes. I get PW1 and PW2. And then I say, if they don't match, then I want to try again. And then I reset them so that when I come up to the top, PW1 is again going to be equal to blank. It's not going to be equal to what I just typed in, which failed. It's going to be blank. So then I come back in, type in a new 1 and 2. And if they do match, then I skip this if clause. So they will match. I skip this. When I come back up, PW1 is not equal to blank. So that's how I'm kind of automatically jumping out of the while loop. If I'm allowed to keep it by not resetting it, that's how I'm going to escape my while loop in this instance. That's just how I thought of it. You could, maybe set it up a different way, but this one, functions at least. And then the second thing that I did, you see I have a kind of a long if clause. The second question is, if PW1 is equal to blank, then I also do try again. Because if we think about it, if we set these equal to both be blank, and then I ask someone to type in a passcode, what they could do is just leave it blank at the input and just put in a blank, and then PW1 would be equal to PW2, even though it's blank, and they would allow it to go on, even though it's blank. So let's type this all out and kind of see it in action, and then hopefully that'll make sense to you. If you want, you could implement it a different way if you want. Again, that's just the way that I kind of thought about it. Okay, so we'll come in and say up at the top, PW1 is equal to blank, PW2 is equal to blank. We can go ahead and write it like this. We can see on this side, I did them on the same line, which is allowed in Python, PW1, comma, PW2 equals value 1, comma, value 2. That's just like an abbreviated way to do it on one line, which I just put so you can begin to see kind of like high-level Python. But since it's just as an intro class, we'll just put it like this, each kind of data point on its own line. We'll say, what is my condition now? Well, I'm just going to say while PW1 is equal to blank. That's just picking one. This could be two as well that kind of both mean the same thing. So while any of them is blank, we'll just get into the loop and keep going. While it's blank, prompt to get one, prompt to get two. If they don't match, try again and go back up. And I actually don't even need this else loop. Else, I'll just kind of add this. If they do match, we'll say do match, then I don't reset PW1 / PW2, so I escape the while loop. I'm just going to leave a comment kind of explaining. And we just had to add the one last thing in. If they don't match, I need to actually do that reset, so I stay inside. So I do PW1, PW2, and set them back equal to be blank like that. Yes, a question, does that equal that? So no. So if we take a look at the console, if we do something like this, that'll come out to be false because this one is a totally blank string, while this one, what's inside of it is a blank white space, which is, not quite the same. So yeah, depending on what you want, you'll probably want to leave the space out in the middle if you actually mean totally nothing inside of that string at that point. So in this case, we don't want this, we just want this. So let's see, I think we typed in everything we need now. Instead of going on to the next step, I'm just going to say, put a little print statement, just so I can check this one bit of the code and see that I get this. And then once I know this stage of the function is good, we can move on to the next steps. So let's come in Python w3.py. What do we need to do? We need to call the function, it looks like. Let me come back down. Call the function down at the bottom below the function definition. Let's try that one last time. Enter a passcode. Now we can see the new line. So I had this one, then I jump to a new line, and then I tab in just so it looks a little fancy. It's not something you need to do. I'll just type in a P. Let me type in X. Try again, maybe a P, and this thing we can see we can keep going. So that looks good. And then let's finally match. Oops, had my caps lock on. And then they match. And now let's try one last thing. So I'm going to run this again. And then what happens if I just click the enter key and type in nothing? That is good as well. So we keep going back, I guess, until we finally match like that. Okay. So let's move on. Let me move that. So we have prompting to get them both twice and they match. So that's good. And now we'll move on to do the simple length check. This one is a lot less code. So we'll come in and say if, and we'll use that length function that we talked about a little bit last time. And at this case, P1 matches PW2. So I can just basically choose one and use it the rest of the time. I can basically choose PW1 and just kind of leave out PW2 from now on since they match anyway. So I'm going to I'll ask if it's less than or equal to 7. That means I fail the length that it needs to be. So I'll put in a print statement again and say passcode must be at least 8 characters long. And then in this case, we could put everything in a while loop. So if we fail any check, well, this is the thing. If we fail at this point, we should basically give back a false, and then we would have to run the whole function again. We can't just put this in a while loop, because if we fail this check and put it in a while loop, it's just going to keep checking, is PW1 less than or equal to 7 again and again and again. We don't have an easy way of jumping up to the top of the whole function, doing this again and then doing this again. We could implement that, but just to keep it simple, we'll say from now on, if we fail anything, we'll just quit it immediately and we won't loop like we did up this way. So this one's pretty easy. If it's less than 7, we give back false and we kill the function. So that one's easy. And then down this way, each of these will be easy, but we'll need to kind of combine them all at once and maybe set up a loop to do all of these. So we'll come up. We want to check these conditions. So let's just kind of think this out. So we'll say in this case, this might be what my passcode is. This is just an example that will satisfy all the checks. I have a capital, I have a bunch of little case, some digits, and an exclamation point. So this is just an example of what check. And then this is what we'll need to do. So since we kind of need to look at this bit by bit and say, okay, this is a digit. At the back, we have an exclamation point. At the beginning, we have a capital. What we might need to do is set up a loop, and then we'll get access to each bit in the passcode one at a time. And then we can do all the checks on each bit as it goes by down the list. So what we'll do is we'll set up that, and then let's just set up a loop just to begin. So we'll loop the whole thing one at a time, and then we'll get this, 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 this. Each of those one at a time, pretending a space is, a pause in the loop. So we'll get access to all of those one at a time. So on the initial loop, we'll just have the P in hand. And then what we'll need to do is we'll basically, again, at least in my implementation of this, we'll do all of these checks on each bit of the passcode, because at any point we could pass one of those tests. And then we'll basically need to keep a tally, or maybe maintain a bunch of switches, true false switches, to see if we hit all of these. And then all the way down at the end, we'll put a little step above this. Did we pass all the tests? And that's when we give back true and false. So up this way, we have the loop. And we just see we need to keep track of if we pass the tests. So what we'll do up above this actually is we'll make a bunch of switches. We could keep a count. Like if you needed at least 5 digits, you might need to count things. But because we just need one of each, we can make everything kind of a Boolean switch. So we can do something like this. We'll make a switch and set it equal to false, or make it equal to like off to begin with. And we'll just make each of these 1. And what we'll do with all of these is inside this loop, we'll check each of these one at a time. And anytime we hit any of them, we will trip the switch, it'll go to true, and then we'll just need to check at the end, do we have all trues or do we have any falses, and see what to do at that point. Okay. So at this point, just a bunch of new methods at this case. I'm just going to give you, some of these as we go. So let me check. Do we have a capital? Well, most of these will begin with like an if clause. That bit is easy. So we'll just ask if questions inside of this, because all of these just constitute a question. So do I have a capital? That's a question. And we could do something like this. This asks if something is capitalized. It's different than this, which we did a second ago, which actually capitalizes something. So this does the capitalizing, gives back a string. This checks if something that's attached to is all capitalized and gives back true and false. So we'll use this instead of this. And then obviously the opposites would be things like, well, actually we'll do that in a second, so I won't even put it on this line. So if I have a capital, I will take this kind of true false switch that I have and set it equal to be true, like this. One thing just to kind of mention, if it's a little bit confusing, when we do something, let me just make a little bit of space. When we do something like this and like a different question. If we wanted to make something called count and then update count, we need to do something like this: count equals count plus 1. With the case of Booleans, we don't need to do like this equals itself plus true. We don't need to do that. We just basically update it like this. So I'm just, kind of pointing that out. We don't need to do this with Booleans, if that stood out to you. Okay, so this is kind of the opposite. This is going to be pretty easy. Same kind of question. If we pass that, we can flip this switch as well. One thing to notice is if I make any typos in this piece of Python vocab, it doesn't highlight blue. This means it's a Boolean value. Python doesn't know what this is at all. I need to make it like it's supposed to be. Same thing with this. You need to capitalize true and false, else Python just won't know what it is. So those two we can handle pretty simply. With the digit one, we know how to do that. We could use the function that we set up down below. So I could call my own function at this point. And I could also use the built-in isDigit function that comes with Python if I wanted to. So it's up to you. Let's go ahead. If you can use the function that we just made, but since you won't always have that function written down in the Python file you have at any given point, I'm just going to use the built-in one in this case. If any of these is a digit, we'll flip that switch. And then the last one we'll have to do a little special. So this one, we don't really have like a built-in, I mean, we might at like a high level, but we don't have like a built-in function to check if something is like punctuation. So instead, I'm just going to do something that we did in the beginning of the class. I'm going to come in up this way. I have all my flags. And then down below, I'm going to make something called specials. And that's just going to be a string which has all of my punctuation symbols in. And then I can use that if something is in specials that gives back true, false. So I didn't even know what it was. I'm just going to put in a bunch of punctuation symbols like this. And let's come back down and we'll just say if in specials, then update special without an S to be true like that. We won't do the last step yet. Let's just come in and say, I want to exit my loop at this point. And what I'm just going to do, I'm just going to look at all of these. Just to see that we got it. And then we'll do that last step in a second. Okay, so we got the match. It's 8 long, so we skipped past this, and we can actually come back up. Passes length check. And let's actually include this with a fancy Fstring, just again to practice all of this. Okay, so we passed this just so we can kind of see on the console that we passed that check. So let's do this one last time so we can see that little tidbit. Yep, so now we pass this pass length check. It's 11 long, that's good. Then we get true, 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 and false. So it looks like everything runs. It gets to the end of the program, so we don't have any obvious bugs. And it looks like, yeah, we did everything except we didn't have a special punctuation symbol. So we just didn't hit this one. So it looks like we passed it. So we won't do too many checks. We'll just go ahead and finish up the last step to see how to handle that. What we can do now is we basically need to check if we got into all of these. At this point, the simplest, although not the most convenient way, might be to do something like this. And I'll explain it in a second. So this might be one way that we do it. And if we think about an if clause or an if question, usually it's a question like, is something equal to something? Is something less than something? In this case, I just have something, but because all of these values, it's all Boolean values, true and false to begin with, it is a condition by itself. So this is basically saying if this is equal to true, then I pass this question and get to the next one, and then get to the next one and the next one. It's basically the same as asking this, but since this is itself a Boolean, it's kind of redundant to ask the whole question. So I don't even need this is true equal to true. I can just say if it is true, then do the next thing. So I could do this and ask this chain of questions, but depending on how many questions you have, you could get indented quite a lot. So instead of this kind of ugly thing, let's take that away and add one last thing in. This is called the all function. So I'm just going to say if all, then give back true, and else give back false. That needs to go on its own line. Let me add a little statement. Success. Fail. And then the way we use the all function is it takes a list. It takes a list as its input, and if everything in the list is true, then it outputs a true. And if anything in the list is false, because it's asking, is all of it true? If anything is false, or maybe everything, it gives back false. So what I need to do is give all a list. And so what I can do is just make one on the fly. I can just put in a list like this. And inside of it, I can just put all the stuff that I have like this. So I made a list. Each of these is true, maybe false. If all of them equal true, then this question will pass and I go inside, print success and give back true. Else I give back fail and give back a false. So let's check that now that we kind of abbreviated that last little bit of code. I will fail one last time and then I'll pass it to see that we can get it both ways. Oops. Let's see what I did. Oh, I just didn't put the full name of these objects that I put. Hang on one second, it's just not catching up to me. Okay. Okay, yeah, so these, they match. It's 8 long, it's 11 long in this case, and we got everything except the special didn't have a punctuation, so we got to fail. Let's check it one last time, and this time, let's actually pass. So I will put an exclamation point at the end. Oops. Like this. And then we pass all of them, and since we pass all of these, all becomes true since everything in it is true. And then we can go inside of this and give back the true. So now we have the all function as a new bit of Python. So this takes an iterable, it takes a list. If everything is true, all gives back true. Something like this, which you can kind of guess what it is called any, kind of a like thing. It basically takes a list. If anything is true, gives back true. So with any, it only gives back false if every single thing is false, but if even a single thing inside of it is true, then it'll give back true. All, if you have any single false, the whole thing fails. So we have those two things. And that's kind of analogous to the and this that we can like link if clauses with. So we have like something like this. It's kind of asking the same thing. We just ask a whole bunch of questions. And if we pass all of them, then we can pass the whole thing. So these couple things kind of all do the same thing. Okay. So that one was quite long. You could see, obviously we had a couple new things, so you couldn't, guess how to do it to begin with. But most of it was a lot of stuff that we've done in the past. It's just, quite long. So we added the step of doing the pseudocode at the beginning to kind of plan out the whole thing. You just kind of think of how you would do it, in human English, kind of logic out the steps of what you would do as if a human was running this function. And then once you have out all the steps, you just kind of translate the ideas into the actual Python code, switching out, conditions, questions with if clauses, switching out, the English phrase, do this again and again with like a while loop and things like that. And then just stacking a whole bunch of, different questions. And then at the end, we have quite a lengthy function that does a whole bunch of stuff. And at the end, it basically gives back true, false to see if we got what we want. If you have any questions about that, you want to see anything else again, let me know. If not, we'll go on to, the big thing this lesson to do with strings, which is called indexing. Let me make some space again. Let me check that my console. Okay, yep. Okay, let's jump to the handout. And now we'll take a look at something called indexing. We'll talk about it with strings, but the same thing applies to lists. And what indexing is it's a way of like counting and knowing the positions of specific elements within a string or within a list. So if I have the string hello, and I want to know the position of like the E or maybe the O, this is a way of like counting and labeling each position in the string. If I have a list of all the lines in Hamlet, and that could be, I don't know how many lines in Hamlet, a couple thousand elements in a list, and I want to know and pull out, the 500th line in Hamlet, I can do that using indexing, since I'll use the positioning of these elements within the whole, instead of just always looking at a whole string or looking at a whole list at a time. So indexing is a way of breaking down strings and lists, pulling out individual things, getting subsets of things like that. So in indexing, you basically just count from the beginning until the end. And the only really confusing thing is that you don't begin counting at 1, you actually begin counting at 0. And this is not just a Python thing, it's most coding that you would do, most languages. You just begin counting at 0, and then you just count up by 1 from that. So H is not element 1, it's actually element 0. Then E, which is what we would call the second element, is actually element 1. And then 2, 3, and then so on. So kind of two things to keep in mind. Again, count from 0. And then the second thing to kind of note is that hello is 5 letters long, but the last one is obviously not 5 because we began at 0. So it's kind of obvious when we say it out loud, but it's kind of the second thing you need to keep track of dealing with indexing. Because if we want to get like the last line of Hamlet and we know it's, like 1,000 lines, we couldn't index line 1,000 because it's offset by 1. We would need to index position 999 to get what's we might call line 1,000, because line 1 is actually, again, line 0. It's all kind of backshifted by 1. It's a pretty, simple concept, just kind of getting used to that off shifting by 1. Down below it, we see these negatives. But we won't deal with this too much. I just kind of want to mention, you can index beginning at the end of something. So instead of counting from the beginning and going to the end, we can do the opposite, begin at the end and count to the beginning. And this is also slightly confusing. You don't begin at 0, you begin at -1 and then go back to -5. So that way kind of makes sense to us if we kind of counted like humans. But with negative indexing, you don't 0 index, you begin at -1. And the reason that this one, this way is not the same as right to left, left to right, is because we can only use index 0 once. Because when we index something, we don't tell it, begin at the beginning, begin at the end. we just say find index position 0, -1, 5, and it's just going to find it. So if we use 0 twice to mean both the beginning and the end of something, that wouldn't function. So the way people set it up is left to right, as you would usually see something begin at 0. And then if you want to, if it's convenient to you and you want to go from the end to the beginning, that's when you begin at -1. So you have a continuum of like -2 to -1 to 0 to 1 to 2. Nothing is used twice. Nothing is skipped past like that. So that's just something to get used to, all those things. And now let's go ahead and kind of see what that looks like in Python to take something and index something out of it. So let me come up to the top of my file. I'm just going to call something called S. I'm going to call hello S. Let me go ahead and print out S. So I get my hello. And let me go ahead and print out, how do I just index item 0 in S? So what this looks like is just this. So this indexes from position, X, in this case, 0. So I can do this. I get my H just like I want. So this little notation just means don't take all of S and print it out. Just take the one item at this index position. So that's 0. You do the same thing using that negative notation that we talked about, which again, we'll just take a look at, but we don't really need to use this a whole lot. It's just convenient in some cases. So that's pretty easy. And we can do the same thing with a list. Oops, let me actually make a list. So I'll make a list of names again. So I'll say John, Joe, and Jill. And then I can again just print the whole thing by itself by just giving the name of the object. And I can also index the same exact way with strings by just putting these brackets on the end of it and saying which item in that list do I want to print out. And oops, don't want that. And then, yeah, we can see we got John, Joe, and Jill. Index 0 is the beginning of the list, so that's John. So if we take a look, I pulled out John like this. If I want to get the end of the list, I could use the -1, but I could also say 2 like this. Oops, typing too fast. It didn't save. And 2 will give back Jill because again, it's 0, 1, and 2. If I attempt to go beyond how many items actually in the list, if I try to do 6, obviously I definitely don't have 6 items, then we'll get a bug. Python will try to find item 6 doesn't exist. So if you see something like this, something happened, you didn't count correctly, something like that. And things like that. If we have a list of like a couple, 1,000 things, how do we easily find the last item in the list? Well, that's when this might come in handy. We might negative index to say, we don't know how long the list is. Let's just go to index -1, which we know is always the last element in string/list. But we could do it a second way, again, without manually counting. We could say index at position, and then we'll use the length function to find how long that list is. And then obviously what we would need to do is the length of this is 3, but we know this is index 2. So if we want to use this notation, we would just need to -1 to offset to go back to 2, and then we could get the last position that way. If you're new to coding, this whole thing is useful in a lot of cases. It might seem a little funny that we have a couple ways to do kind of the same simple thing, and they might not click into place quite yet. But all of these cases of doing things different ways will eventually be useful and eventually make sense. Okay. So that's just finding one specific element out of any collection string, how to find an element out of a list. And something else we can do with indexing is pull out a sub chunk of a whole thing. So instead of just pulling out one thing, we can pull out a chunk of things. So when we come down, set up a new thing. We'll call this like S1, since I have S above, and I'll call this, well, I guess I'll call it 2. S2. You don't have to type out this one if it's too much typing. You're going to stick with the string. Okay, so I have this basically the same thing. I have a string and a list, both with the library telephone line. And now how can we not just pull out like the 9? How do we just pull out the 6 using index positions? How could we pull out like the 973 if we wanted? How could we pull out like the 376, the 1006? How can we pull out a specific subchunk of the of that object using indexing positions? So it's a lot like the range function, actually. So this is what it looks like. We name the string, and then we use those boxy brackets to say I'm indexing. And then we can kind of see a new notation on the inside, but we can see the same things we've used with the range function. So we see the beginning, the stop, and the step. So let's come back. Let's just review this quickly. The range function itself. So range, we have the beginning, stop, and the step. So I went from 0 to 9. We can see again, we mentioned that beginning, the default is 0, and this is also default of 1. And the reason that this began at 0 as a default is, again, because it's linked to encoding. Anytime you count, including with indexing, you begin at 0. So that's why this also kind of oddly began at a default of 0 instead of 1, which might have made sense to you when we found out about that. But this is why we begin at 0 and get to 9, even though I said go up to 10. You know, if you say count from 0 to 10, you might do that in plain English. But in Python, you go from 0 to 9. And the reason that it does this is that we might be able to use the range function to kind of get indexing positions out of something else, since we can begin at 0 and kind of get to that length -1 with the 9 instead of the full 10. It's convenient to use with indexing and things as well. So that's why they kind of both match up to 0 index in that way. We can kind of leave that behind. And now let's see how we can kind of use this in a like fashion to get out what we want of a specific string. So let's go ahead and print. And let's go ahead and say what we want to get. Get just 973. So if we just want to get the 973, we can come into S2. Again, open up my indexing brackets. And instead of just saying 0, which would get me just the 9, I'm going to kind of denote a range to get. So I'm going to say begin at 0. And then I want to go till, I want to get this chunk. Let me zoom in so we can see it actually. I want to get to 973. So this is index 0, 1, and 2. So we might guess that we go to 2 like this, but let's try that. Well, we can see we got 9, 7, and this is kind of the same thing as the range function. This stop position is also kind of non-inclusive. So if I say 2, I actually stop at 1. Again, we can kind of think of it as a stop sign. We stop ahead of the stop sign. We don't actually go to it or go past it. So if I want to get to index position 2, I'm going to stop at 3, which would actually be the 7. So if I run this now I get the whole 973 because I go from 0 to 1 and 2, and then stop when I finally get to the position 3, which is the second 3. I can do the exact same thing with my L2. That'll give me the same thing. So that's convenient. It doesn't change between strings or lists. You index the same ways. And one thing that we can do Just like range, I've kind of capitalized the stop because it has to be included. You always have to say when to stop indexing. But this is also, these two will be set with a default like we know about. So I could do this, but I could also just do this as well. And if I do that, Python knows that by default, this is a 0, so we don't even need to include it. But one thing that we need to note is that we can't leave out that kind of colon that looks odd by itself, because then if we do that, we just get position 3 and we don't get like until index position 3. So we still need to include the colon, but we don't have to include the 0 because we can assume the default is just beginning at the beginning. So these two do the same thing. We can do that way. Next, let's get to the middle bit, 376. So set this up as well. This is S2 actually. Print L2 index out of that. So with this one, we just have to count at this point and just kind of get used to counting offset by 1. So 0, 1, 2, 3. So we want to begin at 3. And then we want to get to this 6. So that's 0, 1, 2, 3, 5. So that goes to 5. But it sounds like we want to stop at 6. So let's try that quick. And then we can just type in the same thing down this way. And then we can see we began at 3 and then basically got to 5, but stopped ahead of 6. So that's how we can get the middle bit. And now let's just do the last one. Get the end of it, basically, get the 1006. So we'll just do one of them. So we'll do S2, since we know they both look the same way. So we'll look at the string. So we want to get the 1006. And in this case, we can let's see, 0, 1, 2, 3, 4, 5, 6. So we begin at 6. And then, actually, I think I misspoke. In this case, we can just do this. Let me check that. Yeah, so we get 1006. So I actually misspoke. In this case, so the default stop, if I don't put it in this place, it's just go all the way till the end. So I could just do 6 colon, just like I could kind of fully write it out and do something like this, which would be like begin at 6, and then I could manually count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I would want to get to 9, so I would stop at 10. Let's just double check that. And yeah, that does the same thing. But as you can begin to see, a lot of times when you see Python, being taught to you and you look stuff up on the web, you'll see kind of this abbreviated notation like this, and you won't see like the full notation like that. So just kind of make you know that you can do both ways. This is what it means if you just see that kind of colon hanging out by itself with nothing in this gap by itself. That just defaults to go till the end, just like the default beginning is just begin all the way at the left, or all the way at the beginning itself. A couple last things that we can do, and I'll come up to the top so we can see S1 and S2 again. We could do a whole bunch of stuff. Let's say we want to get the whole thing, but opposite. This kind of rings the bell. We've kind of done this with the range function when we counted up to 10, and then we did the opposite and counted 10 to 1. So in this case, we can kind of do something like this using the step, because again, we put it in string, beginning, stop, and step. So if I do something like this, let's play it and double check it. Yep, we can see in this line, we got the whole thing, but back to front. And so basically what we did is say we step by -1, so we kind of go back. And then it's a little bit confusing because the default is the beginning and the default end is till the end. But since we have the -1, it just kind of switches those and says the new beginning is the end, and the new end is the beginning. So if we want to flip it, we always have to have this funny assume both defaults, but then say -1. We don't need to put anything in this. And then again, just like the range function, if we want to get like every opposite thing, we could do something like this. So count by 2s. Let's see what happened to that. Oh, I didn't put my 2, that's why. Yep, so we can see this. So instead of 9, 7, 3, 3, 7, 6, we got the 9. Then we skipped the 7 and went to the 3. Then we skipped the second 3, went to the 7. Skipped the 6 and went to the 1, got the 0, and then that was it. So we can also skip and change the increment up and down by using the step, just like that. So a lot in this, a lot of new notation, but it's just different ways you can use it all. And it's all just based on what do you want to begin at, what do you want to stop at, and what do you want to step by. And that can go up and down, skip by 2, skip by 3s, and so on like that. Okay, so now we know how to kind of manually chop up strings and lists. So if we had a list of all the lines of Hamlet, we would know if we needed lines 76 to 90, we could do that using 76 colon 91, you know, something like that. So that's useful that we can do that if we know what we want to get to. But what we'll do next is how we can kind of automatically detect the place that we want to split something up at. So we'll do this example real quick, and then it'll probably be the last thing we do in this class. And then the thing that we'll do the last class, next class, it's kind of a big project, is building a whole like encryption function to kind of encode and decode a string and make a fun little project with that. But with this one, this will kind of combine everything we did with strings and indexing and things like that, and give us a whole bunch of new tools as well. So let me set this up. I'm going to delete these just so I don't have my console bogged down by things. And so what we want to do in this one, so in this one, we'll be taking a list of email addresses. We could take a single email, we could take a list of email addresses. And basically what we want to do is we can see these emails all come in the same fashion. It's someone's given name, dot last name at some company or at Gmail or at college.edu. And what we want to do is use Python to automatically detect and pull out just John Doe, just Susie Blue, do it all automatically and get a nice list of just names instead of email addresses. So we'll be using indexing a whole bunch to kind of chop up these strings, pull out the last name. We'll use some string methods to capitalize the names and things like that. So let's make some data points to begin with. So I'm just going to make one email. So I'm just going to do john.doe@company.edu. And then we'll go ahead and just call get names. And we'll give it this email that we just made. And obviously we would call the function that we haven't made yet. So let's come up above it actually and make the function get names. I'll fill out this quick. So it takes in email address in the format name. So again, we'll be just taking, we'll just be kind of extracting John Doe from john.doe@company.edu. We'll do it with just one name, so we won't set up a loop. We could do it with something like this when we would have a whole bunch of names, Susie. And so on. And then you could imagine all we would have to do in get names, instead of expecting an email, you would just expect emails, and then all you would have to do is just make a loop at the beginning and then do all the steps that we set up to each email at a time. But we'll just do one email at the moment. But in the handout, you can see how you would do it with a list instead of just an individual email address. Okay, come down, put in this to kind of say this is the end of the function, and then let's kind of do all the steps that we need to do. And in this case, we'll do pseudocode to kind of explain the problem in like human speech, and then we'll swap it out with the code because again, a lot of the code I'll just give you since it's so new, but we can do the pseudocode steps. So step one, if we had something like this, what would you do as a human to kind of pull this out and just get John Doe? Step one might be kind of remove the @company.edu, or we could say remove everything past the @ symbol. So we could just chop off the end of the email address. That could be step one. Step two might be to kind of, once we just have john.doe and we've left off the @company.edu, split up like john.doe into John and Doe, so we get both names by themselves. Then we might say, once we have John and Doe, we could, capitalize each name. And then finally, just as a quick step, recombine name plus last name into one full name, something like this. So in the end, we'll take this and we'll get to this. And then once we have that logic, we can take a list of 1 million email addresses and use this one simple function to process all of them at once. And we could do it with any type of email address, as long as they have the same type of setup, name dot last name, and then this could be at company, at apple.com, at gmail.com. As long as it's the same basic type of problem, we could use this function in all of those cases. Okay, so the new code that we need, how do we just remove this @company.edu? Well, we know the exact place that we'll always split it up, since all email addresses have the @ symbol. And so what we can guess, since we know how to index at specific positions, the next logical thing would be, how do we find the index position of a given thing like the @ symbol? So what it would look like is we'll take email, and it's going to be called the index function. We'll just type this out. Let me play this. We can see it gives us an 8 all the way down this way. So what this is basically doing, looking at it right to left, we take email, which is john.doe@company.edu down this way, applies the string method .index. So it's going to do something to that string that we have. It is basically going to give us the index position of the @ symbol. So if we look at john.doe this is position 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So that's a nice function to have. Now we can know what we want to find, get the index of it automatically. And then once we know the index, then we'll probably be able to see we have the index. Let's split it up. Let's use that string notation, the indexing, to split it up at that point. So we get the string. And now let's go ahead and do the split. So let's see. We can take out this, since that was just checking. We'll just call this the front of the email. So I'm going to say front is equal to email. And now that I have the index position, I know I want to leave out everything past index position 8, or I want to keep, we should say, everything above index position 8. So what we can do is we'll index and say we want to begin at the beginning. So we could put a 0, but we could just leave it blank. And what do we want to go to? Well, we want to go to that 8, but obviously instead of just putting 8, we will put the split, so that depending on which email it is at that given case, it's always going to be dynamic and unique to that email address in that case. So we'll just check that. Yep, so you can see we went to position 8. So we took john.doe@company.edu, And then we automatically said, take email and chop it up and only give me back everything up until position 8. And then save that sub chunk just in something called the front of it. So now we did half the job. We took out the back end of it. So that's going to be step 1. So we got john.doe. Now we can go down to this step. So we want to split exactly what we thought we would have when we thought about it as humans. We have john.doe. Let's split it up into 2 objects. We'll call it John and we will call it Doe. This is also a new thing, just like index was a new thing. So I'll just let you know what it looks like. So I'm going to make something called names. Probably going to be a list since we kind of anticipate 2 things. So I'm going to say names is equal to, I'm going to say take the front that I have, which is john.doe. And the function is just called split, which makes sense. So split. And then what we put in its input, what split needs to know to split up front, is just what point you want to split up that thing into. So let me type it in and then we'll see what it looks like and then we'll kind of fully explain it. Oops, let me print it. So you can see we took john.doe, split looks at front, it finds the thing that we give it, which is this dot, and you can see it divides it up as it needs to and actually removes the dot as well. So it takes out the split point. It just gives me things on the left and the right of it. One thing to mention is if we have something with multiple split points in it, like this, if I put a middle name on this email address, what it's going to do is it's going to split it at each of those points. So it's not always just going to split it in half. It's just how many points that you have that can be split. So since I have 2 dots in it, it's going to give me back 3 objects, John, the middle name, and the last name, like that. So split can do as many times as you want. So now I have just my names. So now I have something like John and Doe. And now in this case, so we got kind of the new stuff out of the way. We know how to capitalize. So we just need to do a little bit to kind of clean up this list of 2 names, capitalize it, and then make it back into one single string, which is just John space Doe. So we can make a new object. We'll call it new name, I guess. We'll just make a blank, and that's what we'll kind of save to kind of stuff the new stuff into once we clean it up. At this case, we need to kind of take the items of the list, John and Doe, one at a time. We could do that by doing something. We could do something like this. We could say, do something to names index 0 and names index 1, and then do the same code to each of them. So we might have like 2 steps on each of these things. But like we said a second ago, if we happen to be doing this to a list of emails that had a middle name, then we would have to fix this code to add on that last, the middle name in the list of names. So we won't do it like that. What we'll instead do is just take names and just split it up with the loop. And then any amount of names that we have will access each of them all the time. So we don't even need to know in advance how many names that we might have. We might use this with email addresses with 2 names, and we could also use the same exact code if we had email addresses with a full name like that. So for name and names, we'll get back access to each name at a time. So we'll do a loop of just John, and then we'll do a loop of just Doe. So we'll say, in this, just thinking about it, we'll just look at John to begin with. Take a look at John. We'll want to basically capitalize it. The capitalization function that we looked at, that's going to capitalize all of John. So if I did this, it's going to give me something like this, which is not what we want. So we just want to capitalize the J. So what we actually need to do is we can use indexing to get just the J and then get the OHN by itself, still not capitalized. So we'll call it N, but we want to get the J by itself. What we can do is we can take name and index out just the beginning of it. So I'm going to say index 0, which is just the J. And then I'm just going to attach on, capitalize that. And then what we want to do is grab the OHN, or in the second case, we want to get the D and then the OE. So we'll take this capitalized front bit and then stick onto the end of it the rest of name. So we'll put name, we'll index, and we'll say, if we want to get this bit that begins at index position 0 and 1. So we'll say begin at 1, go until the end. So we can just assume the default of the end of the whole thing. So we'll just leave that blank. And then we'll save that as N. So just again, we take just the J, capitalize that by itself, concatenate that string with a second string, which is just the end bit of the original name, which is just the OHN, and then stick it to that. And then we have a new name, which I just called N, which should be the capitalized name. So let's take a look just to see that we did that okay. Yeah, we can see down in the print, we got JOHN, we got DOE capitalized correctly. And again, it wouldn't be the same if we just did something like this, because then we would be capitalizing the whole thing like this down below. So that's why we can't do this. We have to index just the beginning of it by itself. And then the last thing we need to do, we get John in loop 1, we get Doe in loop 2, but we haven't saved them yet. So when we do the John, we get to John down below, and then we loop back up to the top. And then we process Doe, and we kind of delete the last value that N had on the initial loop. So what we need to do is the last step within each loop of this is just add on to the full name so we can save each bit as we process it. So we'll say full name plus equals N. So we'll add on John, and then we'll add on Doe like that. And then let's see what that looks like. So I'll exit the loop and print the whole thing at the end. See if that comes out okay. And looks like we almost got it. We just need to do one last thing. So we'll come in and say, maybe instead of this, we'll kind of break it down. We'll say full name is equal to N plus, oops. See if this reconnects quickly so we can finish the class in a second. Let's see if it saved it. Okay, so we'll say to the blank full name, just like that blank slate, we have waiting to take both names. Add on to full name the N, which is the John and the Doe. And then we'll just end it with not a blank string, but a string with a blank space in it. So we have the space in between. Let's try that. Python w3.py. Did it do it? Oh, I see what it is. We'll do plus equals. So I take full name, add on John plus a space, and then the next time when I get to Joe, I'm going to take the full name, which is just John at this point, add on Doe, and then add on a space again. Let's try that one last time. Yeah, so now you can see we have basically what we want with just one little bug, which we almost can't tell. So we can see we have John Doe, we have the space in the middle, but because I needed to add a space in the middle following John, logically, I also added on Doe and then added a space on the end of it. So we can't really see it, but it is still, you know, kind of bad data that we've made. We just have a bunch of names with white spaces on the end. So one last thing that we could do is say, we'll just do it down this way, is we'll say full name is equal to full name, and then one last method, and this is just called the strip function, and it removes leading, trailing white spaces. So let me play this. And then you can see we have John and Doe, and we have John and Doe. They look the same, but this one has the this white space at the end of Doe plus white space. And then we come and use the dot strip function. And now it's just John space Doe, and the space at the end of it deleted. We can see we have the space like this, but we don't have the space down this way. And it just deleted that out as well. That can also remove the white space if it's at the beginning, but that doesn't apply in this situation. So it just takes out the space at the end of it. And then last thing we need to do, we can move this up, is we just need to give back full name. So we got the full name. We'll say this is equal to name when we call the function. And then we have that data saved down this way. So you can see we did a lot with this one, but you can see how useful indexing becomes once you know how to split something up by indexing a position. And then especially once you know how to find the index position of something you need, and then kind of automatically say, find this bit, split it up at this bit, do a whole bunch of stuff, split it up as you need it into the front of something and then the back of something, and then do all the kind of stuff that you would need to do. You could imagine like a project if you needed to deal with the whole play of Hamlet. Let's just open that up. If we had the whole play of Hamlet in just one long string, we could just have Hamlet equals and then have this whole thing inside of it. We could make this into a list by doing kind of the same thing we did with this when we take the whole string, and then we could do some things to say like detect. We'd say kind of the split point is something that's a name in all caps with a dot followed by a new line. So we could use that to kind of say, find each of these lines by themselves. So we have a name capitalized and a dot, get everything that follows, a name and a dot and a new line, get all of this stuff. And then anytime you get a name, dot, and a new line, that's when you make a new item in the list. So finding things like that would be a bit of a step up, since we would have to not just find the @ symbol, but we would need to detect kind of, do we have a capitalized name? And we could do that a couple different ways. We could have like a list of all the names and just check, does this match what we have in the list of names? And is it all caps? That might be the easiest way to do it. But we even have ways beyond that of just saying, do we have something all caps? And then we could split it up that way. So that'd be like an actual application of this kind of idea. Not that this itself isn't an actual application. In this too, we could use, if we had like a website that we wanted to pull a bunch of data off of, say they had a company directory, but they didn't have a nice way that we could kind of copy and paste those email addresses off, and they didn't have like a file that you could download. We could use Python to web scrape that website. And then we could use a bunch of things to automatically take all the stuff on that website, just find the list of email addresses, then take those email addresses and do what we've just done. And then we could write a program to kind of do that all automatically. And you could, pull a million names off a website if you just set up a little bit of code to do that. That's kind of the actual use of these types of things that we can do. And then in next class, since we went a few minutes past, we'll do this bit. And this will be the final big project. And then at the end, we will also do the last kind of key piece of data in Python, which is the dictionary. And it has like analogs in different languages as well. It's kind of like a list that's kind of like one step up from a list. It has an advantage on lists that kind of completes the total set of data objects you might need to kind of do anything. So we'll also add that in the last class as well.